So we're going to look at now what happens when all of those amino acids in a long string get together. How do they interact? And you'll remember at one stage I found it quite important to tell you that if an amino acid has a very small R group like alanine and glycine with just these tiny bits that don't get in anybody's way, then you can get something happening. And this is what happens. So what I've got here on this board, because I can't find a slide that shows me this, I've got the CCN. Sometimes it goes the other way, depending on how you draw the diagram. But that's the basic structure, the basic skeleton of an amino acid molecule. So there's the CCN, peptide bond between them. CCN, peptide bond between them. And that's supposed to be a C, and there would be an N there. And they've got bits sticking out of them, of course. And here, I'm kind of ignoring the R groups because they're tiny and insignificant. It's not something like this, which has a massive, great R group sticking out. What I'm going to do here wouldn't work with that. It would get in the way. It would totally interfere with all the bonding. So, what we've got is this stuff. Now, with a CO bond, the oxygen is massively electronegative, and there's a delta negative. With an NH bond sticking out there, we ignore the N because it's in the middle, is a delta positive. Here, there's a delta negative. Here, delta positive. You see the sequence appearing, and this would also have a delta positive. I'm not sure if I'm still on the screen. Yes, I am. So, what happens now is this is a very long string of amino acids, and I've only shown 3 of them. But what if it coils round? What if it coils round to here and makes N, C, C, N, C, C, N, C, C? And if we start putting stuff here, so on the top of the N, there's an H, delta positive. And there here is going to be that, delta negative. And here on the N, there's an H, delta positive. And here is stuff. On here, there's an oxygen, delta negative. Here, delta positive. So what I want you to get the idea of is because a polypeptide is a whole bunch of amino acids put together, they have this repeating structure. So if at one point a delta negative attracts a delta positive, just like with water molecules and their hydrogen bonds, then a little further on, exactly the same thing's going to happen. And the same distance on, the same thing is going to happen. And if we put another one up here, then you're going to get an O, delta negative, N, and you blah, 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 O. And however many times I choose to do this, you can see that we're going to get the repeating pattern. So if there's a tiny number of, a tiny R group that's not going to get in the way, we can form this sort of thing. And I'll show you what that is in a minute. So, let's just go back to, oh my goodness, let's just go back to our peptide bonds. Sorry, I have made a complete mess there, but let's have a look what we've got going on. So let's just revise what we looked at before when we've got a carboxyl group and an amino group together in neighbouring amino acids. A water molecule can be formed, and if that goes away, then condensation occurs, water's given off, and we get this peptide bond formed between the 2 amino acids. And then if that happens more and more, so here's glycine with its tiny little R group, here's alanine with its slightly bigger R group. You'll notice the whoever drew this diagram hasn't bothered to put the H's on. Why would they? And here's valine, which has a slightly more complex R group. And we put them together, we take away the H2O, and these 2 are going to fit together. And there's a tripeptide. It's not a term that's used often, but you can see that we're building up to a polypeptide. And here is a polypeptide, and we see NCC, NCC, the usual sequence to show that it is a series of amino acids. And you'll notice that here is a side with the end with an amino group, and here is the end with the carboxyl group. And they can be labelled the amino end and the carboxyl end. And so here we've got the primary structure of an amino acid, of a protein. It's just the sequence of amino acids: glycine, proline, threonine, glycine, threonine again, blah, 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 blah. And one side is the amino end, and the other side is going to be the carboxyl end. And what we looked at the beginning of this video was if we've got tiny R groups, such as with glycine, and I don't see any alanine, here's an alanine, then we can produce that repeating sequence of bonds that hold it together.